Hello again. Yeah, for those who haven't seen me earlier, hi, I'm Andreas. I work at Twig in the Scalable Builds group. And in this talk, I'm going to talk to you about Hermetic shell scripts in Bazel. So when I say shell script, what do I actually mean? Well, I really mean any action that invokes some external or some tool, some binary, some other thing. It might be, like a common example would be a gen rule, but it extends to other examples. But for this talk, I want to work through something concrete, and so I'm looking at a gen rule. Let's look at a simple, silly example that's designed to fit on a slide. So this here is a gen rule that generates a mapping from a package name to the license it uses for a package defined in a package JSON file in a tarball. It takes as an input a tarball, and then it generates as an output this mapping file, which is just a text file. And the way it does this, it first invokes tar to get out the package JSON file, and then it uses JQ, the JSON query tool, to pick out the name and license fields and write them into an output file. It's designed to fit on a slide. All right, but in reality, this could be something more complex, like perhaps a gen rule that invokes a third-party build system to build some dependency or something like this. And I'm using a gen rule for illustration here, but really this extends to any kind of action that invokes other tools. So this could be a custom rule with a shell snippet or a rule that invokes a runner binary, like a Py binary that invokes other tools, Anyway, so what's the problem with this kind of example? What are the risks? So if we look at this gen rule, what are the dependencies of that gen rule? They're the sources, of course. We declare them as dependency. But then there are more, right? This thing also depends on JQ, the JSON query tool. And it also depends on tar. And we often assume that these things are sort of just there. But they are dependencies, right? If they're missing, this thing is going to fail. So it's a dependency. But we haven't told Bazel about it, because as far as Bazel is concerned, those are just strings, right? So what could go wrong? Well, I mean, the tool could not be installed. JQ is not a standard tool, right? It doesn't come with your sort of standard installation. You have to tell the operating system to make it available. What about tar? I mean, on Unix systems, you can expect that tar is there, but maybe you have a project that's also supposed to build on Windows, and you're expecting that MSys is installed to make tar available, and it's not. Well, that could be a problem. Another problem could be that these tools just have the wrong version, right? I mean, JQ is somewhat recent, at least compared to tar, so you might expect that features change over time. And even tar can depend on the circumstances, right? Like GNU tar is different from a BSD tar. Yeah, when it comes to Windows, you could also have the issue that you accidentally find the wrong tool. So you might expect a find provided by MSys, but you might end up finding the Windows native find, which is more like grep. And what I'm trying to get at is these are not just theoretical issues. I've seen all of those happen in practice. A common thing is onboarding, like new people join the team, they forget to install stuff, or it's a cross-platform project and the Linux developers break the macOS build because the whole GNU versus BSD thing, or CI changes, like update of the base image or something, the environment changes, the order of the path changes, whatever. You get unexpected tools in your actions all of a sudden. So how can we solve this problem? So yeah, let's make those implicit dependencies explicit, right? And then Bazel will help us avoid these issues. Make all your dependencies declared dependencies. In this talk, I would like to introduce SH binaries, which is a new rule in the rules SH rule set that we maintain at Twig. And that one is designed to be explicit, so to track these kinds of tool dependencies explicitly for Bazel. It's designed to be composable so that you can define a bundle of binaries that you would commonly use and compose it with another one and so on, because you don't want to always track tar as an individual thing necessarily. That gets pretty tedious. And it's designed to be compatible, so it exposes those tools through make variables or providers, so you can use it in gen rules or the args attribute or in custom rules. So let's see it in action. Here we define a tool bundle with this new SH binaries rule, where we say that JQ and tar are sources of this SH binaries bundle. And these JQ and tar, they could be downloaded binary distributions, they could be checked in source, they could be generated by Bazel if you build them with Bazel. They could be symlinks or shims, or they could also be pulled in with Nix, with rules Nix packages, if you saw my talk earlier today. And then how can we use those in a gen rule to make it hermetic? First, we depend on this tools target as a toolchain that makes the make variables available. And then we can reference these tools through those make variables that the tools target provides. Or if that's too invasive, like if you have a shell script that you invoke or something, you can also, there is a make variable for a path that extends path with those tools tracked by Bazel, and then you can use them this way. Those who are familiar with rules SH already might be wondering how this relates to the POSIX toolchain feature that we have in there. So SH binaries is somewhat a more general approach to this, where you can combine arbitrary tools into a target and then compose those targets as well and track these that way. POSIX toolchain initially was built on still pointing to external absolute paths, which does enable a hermetic build if you're setting up those things with Nix. But in other use cases like Windows, or if you just have those things installed globally, ends up being inhermetic, because if you extend the path with just /user local bin or something, well, you get more than you might have asked for. We're also planning to upgrade the POSIX toolchain to one that is based on this new rules SH binaries rule, and then would be also hermetic in more general use cases. So in conclusion, shell tools are often forgotten, but they are dependencies too. Make all your dependencies explicit, avoid implicit dependencies to get correct builds. And you can use rules SH's SH binary rule now to do this for tools and make them easily accessible in gen rules and other kinds of shell script-like actions. Finally, I'd like to say I work at Tweak in the Scalable Builds group. If you're interested in what we do or would like to work with us, take a look at this blog post where we introduce the team, or get in touch here. And we're also hiring, so if you're interested in the work we do, then take a look at the career page or also get in touch with me. Thanks.